I'm going to go on and go over what's called sigma notation, plus some special formulas associated with them. This symbol means add up. We're going to add up AI's, A sub i's, where I goes from 1 to 4. So basically I want to know what this is when I is 1. And it's A sub 1. Plus, for sigma means plus. And now I is 2. A sub 2. And then I is 3. And then, don't go past 4, then I is 4. If you were asked to solve this, the summation as I goes from 1 to 3 of 2I plus 1 over 5. So first I is 1. I write down what this is when I is 1. It's 2 times 1 plus 1 over 5 plus. Now I is 2. So, I mean, to basically think of this as f of I. Instead of x, it's I plus 1. So now I is 2. So instead of I, you put 2. 2 times 2 plus 1 over 5. And then last, I is 3. So it's 2 times 3 plus 1 over 5. So we are adding fractions, and they're all over 5. The numerator, 2 times 1 is 2, plus 1 is 3. 2 times 2 is 4, plus 1 is 5. 2 times 3 is 6, plus 1 is 7. So we're really adding 3/5 plus 5/5 plus 7/5. Well, they're all over 5. 3 plus 5 is 8, plus 7 is 15. And it's amazing how 5 goes into 15. I get a nice answer. This max equals 3. That is, this equals 3. Whenever you see I, you cut in the lower number first, all the way up to the top number. What do I mean by lower number and top number? This time I'm just going to change the letter. The variable is going to be k. The number I just wrote now is the lower number. The number up here is the top number. Suppose you had k squared. So first k is 3. K is 3. So write this, except instead of k, write 3. Plus. Now k is 4. Now k is 5. Now k is 6. And you get 9 plus 16 is 25. 5 squared is 25. Well, that's 50. And 6 squared is 36. When you add these numbers, you get 86. So if somebody asks you what this equals, you say, oh, that's 86. Okay, that is sigma notation. Now some basic rules. If you have a sum, suppose you have the summation of AI plus BI. And I goes from 1 to any number, n. Well, first I is 1, so you get A1 plus B1. Let's just go up to 3. I go from 1 to 3. Then you get A2 plus B2. And then you get A3 plus B3. But these AIs and BIs, they're real numbers. The order you add these up are up to you. I choose to add the A's first. And then I choose to add the B's. And then I say, oh, you know what's in here is the summation of AI's as I goes from 1 to 3. Plus, oh, those are all B's. And they're being added. So, good summation symbol. BI. I goes from 1 to 3. Okay. What is it that I'm trying to show here? Trying to show that it distributes. You get the summation of AI's plus the summation of BI's. That's just what it says here. So you had the summation as I goes from 4 to 7, for example, of a constant times AI. Well, first I is 4, so you get 7, constant is not 7. Constant is K. You get K, A sub 4 plus K times A sub 5 plus K times A sub 6 plus K times A sub 7. Well, you can factor out K. K times A sub 4 gives you this, plus K times A sub 5 gives you this, plus K times A sub 6 gives you this, and then K times A sub 7 gives you this. That's K. But what's inside the bracket is the summation of A sub i's as I goes from this number to that number, 4 to 7. Oh, you mean I could have just put the constant in front. For example, if somebody asks you what's the summation of 3 times n squared as m goes from 4 to 6, rather than doing 3 times 4 squared plus 3 times 5 squared plus 3 times 6 squared, and you're going to get bigger numbers in each of these circles because you're multiplying by 3. Here you're going to get 3 times 16. Here you're going to get 3 times 25, 75. Here you're going to, I think, break 100, 3 times 36. Instead of doing that, you can factor out the 3. It's 3 times the summation as m goes from 4 to 6 of m squared. So it's 3 times what's in the bracket. What's in the brackets is the summation. First m is 4. It's 4 squared plus 5 squared plus 6 squared. It's 3 times 4 squared plus 5 squared plus 6 squared. 16 and 36 is 52. So 52 plus 25 is 77. And 3 times that, I think, is 231. It's a lot better than saying 3 times 16. Well, that's one multiplication, plus 3 times 25. That's the second multiplication. 3 times 36, 108. Rather than doing 3 multiplications and then adding larger numbers, I'm just adding 3 numbers and doing 1 multiplication. It's a bit simpler. And putting these two concepts together, you can have something like this. You have the summation of r times a sub I plus s times b sub I. And I don't care where the i's go from. Well, since it's a sum, you get the summation of the first plus, and if it was minus, the summation of the second. But the summation of the first, that r can come in front, plus minus. The summation of the second, the constant s, can come in front. Okay, these are good rules to know. Now, there are very special rules that you're going to have to know big time for next section. You have to know what the summation of I, as I go from 1 to n. That is 1, first I is 1, and then it's 2, and then it's 3, all the way up to n. You need to know what that is. And since it's sum, we'll call the result s. For example, we want s is equal to 1 plus 2 plus 3, all the way up to, well, the last number is n, and the number before that will be 1 less. Just like the number before 3 was 1 less than 3. Number before 2 was 1 less. Now, s is surely equal to, I'll just write it backwards, n plus n minus 1 plus n minus 2, all the way down to 2 plus 1. I just wrote it backwards. 1 plus 2 plus 3 plus 4, all the way up to n. Okay? So if I add the left side, I get 2s. I get 2 times what I want. I want to know what this is. That is, I want to know what s is. Now I have 2s. For something clever is going to happen. When you add those numbers, you get n plus 1. When you add those numbers, you also get n plus 1. I mean, if I make one number 1 larger and the other number 1 smaller, the sum is going to still be the same. These add up to n plus 1. These add up to n plus 1. These add up to n plus 1. That is, I have n plus 1 plus n plus 1 plus n plus 1 plus n plus 1 plus n plus 1. So I'm going to end up with some number times n plus 1. And after all, if you keep adding up 7, if you add up 7 6 times, you get 6 times 7. Well, I'm adding up n plus 1s. The question is, how many n plus 1s am I adding? It's very bad to say, oh, this is simple. 1, 2, 3, 4, 5. That's not true. There's many, possibly many n plus 1s there. The nice thing is, the top numbers are counting for us. This here is the first time we added up or obtained n plus 1. Oh, and there's a 1 there. How nice. This was the second time we added up n plus 1. Oh, there's a 2 there. Counting for us. Here's the third time we added up n plus 1. What do you know? It's 3. The last time we added up n plus 1, we added on n plus 1, that was the nth time. So we are going to get n times n plus 1. That's what 2 times s equals. Dividing both sides by 2, we get s is equal to n times n plus 1 over 2. But what was s? S was the summation of I. That is, the summation of I, as I go from 1 to n, is n times n plus 1 over 2. As long as it's starting with 1, I like to read this as, it's this number times 1 more over 2. Let us work with this. remember that the summation of I as I go from 1 to n is n times n plus 1 over 2. So if somebody asks you what is the summation as I go from 1 to 5, well, it fits right into this so long as you say n is 5. I mean, it has I equals 1, it has I here now, it has the sigma notation, and it's 5. So, you're going to get the same result, except that we got to have on the top, except instead of n, we're going to write 5. Instead of n, 0, 5. And yes, this is I. So instead of n, here and here I put 5. It's n times n plus 1. 5 plus 1 is 6 over 2. And 2 goes into 6 3 times and get 15. And 1 plus 2 plus 3 plus 4 plus 5, that's 15. And 2 plus 3 is 5, plus another 5 is 10, plus 4 is 14, plus 1 is 15. Okay. I mean, another way of figuring out what 1 plus 2 plus 3 plus 4 plus 5 is to add it together 2 times. So whatever answer we get here, it'll be 2 times what we want. You have 6 plus 6 plus 6 plus 6 plus 6. This is 6 times 1, 2, 3, 4, 5. 6 times 5 or 30. Okay, well, since this line and this line are equal to one another, and the sum is 30, the top line is 15, and so is the second line. This is 15. N times n plus 1 over 2. You must know that formula. There's one other formula I meant to give as a basic formula. The last one was a major formula. If you have the summation of k, and I goes from 1 to n, well, you have to remember, if f of x is equal to 13, well then f of 0 is 13. F of 2 is 13. F of negative 13 is 13. Whatever number I put in between the brackets, on this hand, on the right hand side, I replace x with that number. So what is 13 equal when I replace x with 0? This doesn't care about x. It's called a constant. Constant means it doesn't change. It's always 13. When I is 1, k is k. Plus, now I is 2. And I get k. And now I is 3. That still equals k. All the way up to I equals n. When I is n, this is k. How many? Remember, here I was 1, and I was 2, and I was 3, and then I was n. How many times am I adding up k? Well, it counted for us. 1, 2, 3, 10. This is nk. That's an important rule to know. So, let's go on to the next formula. I just gave you the formula for the summation of I as I goes from 1 to n. Now I'm going to up it to I squared. Okay, I actually forgot that row. Have a look here. It's n times n plus 1 times 2n plus 1, and all of this is over 6. So for example, somebody asks you what is the summation as I goes from 1 to 4 of I squared. Well, it looks exactly what I'm circling on top, except n is 4. N is 4. Okay, so on the right-hand side, here and here and here, we put n is 4. 4 times 4 plus 1 is 5 times 2 times 4 is 8 plus 1 is 9. And this all gets divided by 6. Well, 2 goes into both of these numbers, 1 in the top and 1 in the bottom, 2 and 3 times. And 3 goes into this bottom number 1 time, and this top number 3 times. And I'm left with 2 times 5 is 10, times 3, 30. And I should get 1 squared plus 2 squared plus 3 squared plus 4 squared. 1 squared plus 2 squared plus 3 squared plus 4 squared. I love nice numbers like 25. And here's another 5. 25 plus 5 is 30. Might need some silly error. That's what I should get there, and I did. That's the summation of I squared. That is the summation of I squared. As I go from 1 to 4. Now we were fairly easily able to do this on the bottom because I only had to square a few numbers. What if n is fairly large? What if somebody is going to ask you, what is the summation of j squared? It's a dummy variable. Instead of I, I'm putting j. Okay, j goes from 1 to 100. Okay, so n is 100. Or j is, n is 100. So I get 100 for n. 1 more than n is 101. And 2 times 100 is 200, plus 1 is 201. And all of this gets divided by 6. Well, 3 goes into both of those numbers 2 times, and 3 goes in here into 26 times with 2 left over, and 3 goes into 21 7 times. And 2 goes into 150 times. So now you have 101 times 67, which is 707 and 606. So you have 6767. You have to multiply this by 50. Oh, 5. So I put the 0 down. 5 times 7 is 35. 5 times 6 is 30, plus 3 is 33. 5 times 7 is 35, plus 3 is 38. 5 times 6 is 30, plus 3 is 33. Minus some silly error, 338,350. You do not want to compute 1 squared plus 2 squared plus 3 squared all the way up to 100 squared. That would take long enough. Then you're only half done. Now you have to add up these 100 numbers. The formula works well. Okay, and somebody who's studying Calc 1, you need to know that formula, the one on the very top. The next formula that comes up a lot, and fortunately it's the last formula, is the summation of I cubed. This one's a bit friendlier. Remember, the summation of I, as I go from 1 to n, is n times 1 more over 2. Well, when you have I cubed, you get the same thing as I, but everything gets squared. And 2 that I didn't write in the bottom, when you square it, you get 4. Okay, so if somebody were to ask you what is the summation as k goes from 1 to 5 of I cubed, that is no. K cubed. Variable is not I, it's k. That's the variable right there. K cubed. Oh, this is going to be 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed plus 5 cubed is 1 plus 8 plus 27 plus 64 plus 125. Those add up to 35. Added to that, that's 160. 64 and 1 are 65. So I guess the answer is 225. But this formula would work nicer. Remember, n is 5, so it's n squared times n plus 1. 5 plus 1 is 6. Squared over 4. 5 squared is 25. 6 squared is 36. Divided by 4. Well, 4 goes right into 3699. 9 times 25. The value of 9 quarters. Well, the first 4 quarters are 100. The next 4 quarters are another 100. You've got 8 quarters. You have one more quarter. It's 25. That's 225. Okay, so same answer I got using the long way. But if n is large, if n was 100, I wouldn't want to cube the first 100 numbers, nor would I want to add them up. Okay, I'm going to finish off this section by putting the formulas in one location. I might list the first one that I said shouldn't be. If you have, okay, the summation is I goes from 1 to n of I. This is n times n plus 1 over 2. Know this. The summation as I goes from 1 to n of I squared is n times n plus 1 times 2n plus 1 all over 6. You make sure that's correct. Okay, and that's the second formula. And the third one, which I'm going to call the fourth one in a moment, the summation of I cubed is just this square. It's n squared times n plus 1 squared over 2 squared. Unfortunately, the I didn't get squared. We didn't square the I. That's the third formula you must know. And the summation as I goes from 1 to n or some constant is just the constant times n. When I is 1, you get C. When I is 2, you get C. When I is 3, you get C. All the way up to the nth time, this is C. C plus C plus C plus C is C times n. All right, know these 4 formulas. You're going to need it for the next section.